Hey, welcome. Today we are talking about data collection. Data collection is really important in the study of statistics because it's where everything starts. So whether you're a pharmaceutical company trying to run tests on a new drug, or if you are doing a political survey, trying to figure out, doing polls, anything like that, it all starts with taking a sample of the population that you're interested in. And how you take that sample really matters. You can't just pick a random 10 people. You have to be able to pick a sample that is representative of your population. So there are a couple ways to take a sample, and we're going to talk through those different strategies. And there's pluses and minuses to them, and it depends on what you're studying as to which ones you want to pick. So the first strategy is called a simple random sample. And the way this works is that you assign a number to each person or object in your population. And then you randomly select certain numbers. Okay, so, I've got a population of 500 people. I assign each person a number between 1 and 500, and then I randomly generate numbers and pick 10 people to be my sample. The advantage of this, it is truly random. There's no bias in the picking of the numbers, assuming you do that randomly. The disadvantage is if your population's too big, sometimes it's hard to assign numbers to everyone. Imagine if you were trying to survey the United States, maybe that's hard to assign everybody a number unless you can figure out a way to generate numbers easily. For example, you could use people's social security number, but then do you know everybody's social security number? Does everyone have a social security number? Those kinds of issues come up. But when your population's smaller, this is a good option. So I'm going to show you a way to randomly generate numbers on the calculator, so that if you use this procedure in this class, you'll know how to randomly generate numbers. The first place we're going to do this is on the TI calculator. If you guys have one of those, what you're going to do is you're going to hit math, which is this button right here. And then you're going to use your arrow button to go over to the far left. It's PRB, that stands for probability. And then you scroll down to option number 5, and it says rand int, that stands for random integer. And you hit enter on that value right there. And what you'll see is a screen comes up. And in the upper right-hand corner, it says rand int and parentheses. And depending on which TI you have, it might look slightly different, but that's roughly how you go. And it's waiting for you to enter numbers. Now, the order of numbers that you enter is, first, you're going to tell the calculator the range of numbers that you have assigned. So say our population is 500 people, then that means that people have the numbers of 1 through 500. Like that's how we've numbered people. So you're going to enter 1, 500. The comma is right above the 7 button right there. Okay. And then after that, you tell the calculator how many people you want to pick in your sample. So let's say we want a sample of 10 people, then you put a comma and a 10. And if you do that, let me enter mine in really quickly. So I'm going to go 1, 500, 10. And then it's going to kick out, it's going to do a little bracket and it's going to start listing numbers 27, 362, 7. And you can use this right arrow button to scroll to the right to see your whole list. Now, if you hit enter, you won't be able to scroll down the list again. You'll have to regenerate. So use your arrow button before you hit enter, because this list goes off the screen. Obviously, it's 10 numbers. And your numbers will be different than someone else's that runs the same one, because the calculator is producing random integers. Okay, so that's how you generate those. And then I would call up person 27, person 362, et cetera, to get my sample. If you're using ClassCalc, and Desmos works similarly, when you get on that, make sure that you hit the upper right-hand corner and choose your graphing mode on that little calculator there. And you are going to go into statistics. And we are going to the advanced category there. And right here on the left-hand side, it says rand int, and it's the same. Okay, so minimum, maximum, and how many you want in your sample. So we're going to go 1 to 500, and I want a sample of 10. And then over here on the right, it says 10 item list. You just tap on that, and then that gives you your random numbers. Okay, so you'd pull up person 45, person 323, that sort of thing. Okay, so that's how the calculator works with random integers. All right, next type of sampling is called stratified. Whoops. Sample. So in this one, you're going to divide your population into groups, and you are going to select a given number of people from each group. Okay, let me draw you a picture of this. So let's say this is our population. Okay. So I'm going to decide, we'll talk about how to decide, but I'm going to decide how I'm going to divide up this population. So I'm going to pick some kind of grouping here. I'm going to say, okay, here's how I want to group my people right here. So I've got all these subgroups of my population, and then I'm going to decide, I'm going to say, I'm going to pick 2 people from each category. So I'm going to pick 2 people from here, 2 people from here, 2, 2, 2, 2, 2. Okay. Now, how do you do that? You might use a random number sample to pick your 2 people. Okay. Yeah. So there's different ways to pick in that. So in that sense, some of these, techniques overlap, but the basic idea of a stratified sample is that you divide and you pick an equal number from each. Now, how would you divide the group? It depends on what you're studying. So let's say, for example, you want to study a blood pressure medication for a pharmaceutical, and you want to know its effects on different people. If you do a simple random sample, you might just randomly get a group of people that is, say, very young, just by chance. That could happen. And as a pharmaceutical company, you actually want to study the effect of this drug on different age groups. So if age is a factor, you might choose divide your population by age. So you'll say this first group is going to be, your 20 to 30-year-olds. Maybe this is your 30 to 40-year-olds, etc. Okay. And then you'll pick 2 people from each group. Maybe you don't actually care about the younger people. Maybe you're really studying the effects in older generations. Then you might categorize that differently. Maybe you are doing a political survey and you want to know people's opinion on an issue that is largely gender divided. So you might just take your population in that case and just divide it into 2, men and women, so that you make sure that you get the same number of men as women, that kind of idea. You could take, if you were surveying a city, you could divide people by geography. You could divide people by zip code. You could divide them by school district. There's all different ways that you can divide people geographically. Now, there are some problems that can arise with that. If I divide people by geography, there are typically going to be areas of my my geography that are lower income or higher income, and you have to evaluate if that's going to affect your question. So there's a lot of thought that goes into how to divide. You don't want to just randomly divide people. You want to divide them in a meaningful way that doesn't create bias. So that's stratified sample. The next one is cluster sampling. Now, cluster sampling starts the same way as stratified sampling. You're going to take your population and you're going to divide it into subsections of some sort. Okay, so you're going to divide your population into groups. And then you're going to randomly select all of one group. Okay. So in this situation, I'm not going to go into each of my subcategories and pick the same number from each. I'm going to randomly select a whole category. Okay. Now, this creates a different discussion. If I'm going, let's say I'm going to survey my city and I want to divide it up by neighborhoods. If I'm going to take here's my whole city, I'm going to divide this up into all these little neighborhoods like this. Okay, and then I'm going to randomly select a certain number of them. So I'm going to select this neighborhood, and this neighborhood. The problem that could potentially arises here is that what I talked about before, you could be choosing a neighborhood that has a lower or higher socioeconomic status. You could be choosing a neighborhood where most of the singles live versus married, if that matters, that kind of thing. Whereas in a stratified sample, if you take 5 from each neighborhood, then maybe you've got an equal representation. And maybe that matters and maybe it doesn't. So it depends on, again, what your question is. Some thought needs to be put into how you divide these up. Is it just a straight up random geographical split? Do you want to split people by age, by hair color, by athletic ability? All of these things are options for how you select, but then in a cluster sample, we're going to select one whole area or 2 or 3 or 4 whole areas instead of a few from each. Okay. Then we move on to systematic sampling. Systematic sampling is where I'm going to choose every nth person in my population. So this is kind of a math thing that we do. This nth, n stands for a number. So like this could mean I'm going to choose every third or every 10th or every 20th person, that kind of thing. So where you might use this is like if you were doing a store survey to survey people's satisfaction on their experience in a store. You might stand outside of the store and you might survey every fourth person that walks out, that kind of thing. Or if you want to ask a question of Allen Hancock students and their how they feel about the cafeteria, you might survey every 10th person that checks out of the cafeteria, that kind of thing. Again, this is harder to do when the population's large. Imagine doing a political survey this way for the nation. There's no way to you got to number everybody and you got to choose every 10th person. That's going to be very challenging and very time consuming. So again, the question that you're asking and your population size matters when you choose your sampling technique. The last one is not a very good one, but we put it in because it can happen. It's called a convenience sample. So this one is usually what we call a bias survey. They all can be biased in certain situations. There can always be a bias associated with these different sampling techniques, but this one largely is always biased. I mean, it's because it's done in a way that's convenient to me. Let me give you an example. If I want to know how people feel the president of the United States is doing, then I go to my book club and I ask everybody in my book club, what do they think about the president? And then I use that as a survey. That's going to be hugely biased. They're my friends. It's a small sample. We probably or often think similarly. So I'm not getting, the age groups are probably similar. Like if I'm in a book club, I'm probably in that with people who are kind of my age, my socioeconomic status, all that stuff. It's an easy way to pull a sample for me, but it's not representative of the whole United States. So these samples are usually not the way we want to run things. Okay. So those are the sampling techniques. You should be able to read a scenario and identify what kind of technique that they're using. And then there's two more vocab words for this section. One is an observational study. And one is an experiment. And you should be able to tell the difference between the two given a situation. An observational study is just what it says. I am observing. In other words, I'm not doing anything. Now, in statistics, we use the word treatment. I'm not putting a treatment on my sample, and that just means I'm not messing with them. I'm not giving them a medication. I'm not giving them any information. I'm not having them run a mile. I'm not doing anything to them. I'm just surveying them. I'm asking them a question, or I'm just watching them. I'm putting them in a scenario to see what they're going to do. But an experiment, I'm actually going to interact with them. I'm going to give them the trial pharmaceutical. I'm going to, tie a red ribbon around their arm, like whatever that is. I like to say this, I'm going to mess with them somehow. I'm going to give them something to eat or drink. I'm going to have them do something. I'm going to give them some information, see how they respond, that kind of thing. Okay, so that's an experiment, and you should know the difference between those two. Thank you for tuning in. I will see you next section.